Hello everyone and welcome back to Java Forever course. We are learning variables and constant, and today we are going to look a little deeper into memory management. We will look into a problem statement and use memory variables and see how it is being managed in the memory. So as you can see in the picture or in the diagram here, we assume that we have $20 in our pocket and we are going to buy an ice cream which costs $8, and we'll find out how much, if we buy the ice cream, what will be the remaining amount. This problem looks pretty simple or easy because we can see this is $20 minus $8, remaining is $12. But what happens if we have we create a generic problem statement? We say for a given X amount in our pocket and Y is the cost of an ice cream, what would be the change left in our pocket if we buy that ice cream, right? Let's say X is ice cream, so we can say X equal to 20, and I'm going to write a comment here. I'll say X represents money in pocket, right? Then let's say Y represents cost of the ice cream. And then Z is the money left in my pocket would be X minus Y, right? And then finally, this is my core algorithm, core logic to compute money left or change left in the pocket after buying the ice cream. Now, as you can see, I created right now in this context, I am saying X equal to 20. But if you run the same problem statement in a different context, X could be 50 or Y could be, $10. It depends on the values we are feeding into the problem. But the core logic remains same, Z equal to X minus Y. Now, this is how I translated a problem statement in 3 lines of code. What really happens behind the scene is that if you remember my example of a hotel management, let's say this is a hotel, and in which when you say X equal to 20, you say Y equal to 8, and you say Z equal to X minus Y. Let's see what really happens behind the scene. When code executes, this line of instruction executes by the processor, is executed by the processor. It goes and checks in the memory whether if there is any room called X, and if no, then let's create a room called X and set a value 20, because we are setting a value 20 to X. So that is what is precisely happening. This line of code executes by processor. It sends this data to memory and saying, is there a room called X? And answer is, since there is no room called X, then go and create a room and move 20 inside. So room number X is created, 20 is moved in. Then processor goes to the next line and says, is there a room called Y? If not, create that room and move 8 inside that room. So a room is created called Y, and this time 8 is moved in when this line of code runs by the processor. Now, most important thing to remember, processor always works on a current line. Once processor goes to line number 2, it does not know what was written in X. It executed and it forgot. Now, remembering the values is the job of memory. Execution is the job of processor. So when you run this line, processor does not remember the previous line. It always lives in the moment. So the value Y equal to 8 is set. It goes and gives to memory. Memory creates a room. Y 8 is set. Now let's look at the third line. When processor comes and wants to do Z equal to X and minus Y, the first thing it does this computation on the right side. And it says X minus Y, but processor does not know what is X and what is Y. So processor goes and checks with the memory, is there a room called X? And if yes, who lives in X? So memory responds by saying, yes, there is a room called X and the value is 20. So it becomes 20 minus. Similarly, what is y? Memory responds by saying y is actually 8. So this line is actually replaced like this and becomes z equal to 20 minus 8. And now processor can compute this arithmetic operation. 20 minus 8, it becomes 12. So ultimately z becomes z equal to 12. Now z equal to 12 again back becomes an assignment. Processor asks memory if there is a room called z, and if yes, then overwrite. If no, then create. And since there is no room called z, so processor is going to create a room and it will move 12 inside. And that is how the z equal to x minus y is computed. This is really what happens in the memory, right? Couple of things to remember. When you say variable on the left side and value on the right side, you are actually writing to the memory. But when you use variable on the right side, you are reading the value from the memory, right? And then again, you are writing it back to the memory here. That is how a variable in the context of your instruction works. The processor works very closely with memory and manage the variables. The value of the variable is either written or read from the memory and used by the processor. I hope you understand this. I'll see you guys again in the next class. Stay tuned. Bye-bye.